Hello everyone, and welcome to our presentation. This paper is a replicate study about adoption of a STEM outreach program in Kuwait. The authors are Safia Malala, Salah Al-Lakawi, and Dr. Josh Weiss. It's a pilot study examining complications that occur when STEM outreach program from United States was adopted for use in Kuwait. Introducing children to valuable STEM experience, starting at young age, has been shown to improve science literacy, promote critical thinking, develop problem solvers. Yet not all countries acknowledge the need to a STEM education like Kuwait. The K-12 computer science curriculum in Kuwait public school primarily focus on computer literacy and secondarily on programming. Our objective is to understand what a problem might occur when incorporate a STEM from a Western country into Kuwait, to give educators an overview of what needed to be done to carry out computational thinking in the domain. So we want to investigate the factors that influence transferring and teaching STEM program in Kuwait. And does bringing STEM program into Kuwait improve student computational thinking abilities? And what would be the similarity and the difference between Kuwait and Western country over student performance? To teach computational thinking. But what exactly is computational thinking? Although no unified definition of computational thinking has yet been developed, I would call it as the skills for solving problems by adopting the theoretical concepts of computer science. The computational thinking idea can date back to the 1980s, where Seymour proposed it in his book. In 2006, Junaid popularized the terminology. That's led to gain and increase more attention from the research community. One of the research incorporated computer science principles into a sets defined from programming context, which is what we adopt in this paper. The computational thinking sets has 10 concepts, starting from algorithms, control flow, and so on. We adopt those concepts in our experiments. The STEM Outreach Program, the Mighty Microcontrollers. This program focuses on teaching students computational thinking within the context of coding microcontrollers using Arduino and block language. As teaching programming can be a difficult task when involving students who have no background in foundational computer science skills, the curriculum emphasizes reducing this cognitive load through examples and scratch programming environment, which will reduce the complex syntax and the programming errors. Each lesson in this program was designed to highlight the microcontroller software for a very specific computational thinking skill. Dr. Venn derived factors to meet the need for the future knowledge-intensive generation. As young people are now growing up with the smart gadgets that influence how they perceive the world, he suggested 3 interdependent parallel factors: economical, technological, and social cultural. This study complements the 3 factors with sub-barriers that are specific for the GCC country in particular and computer science program in general society. Because GCC country share the same language and culture practice, pattern of social effects on technology are easily traceable. For gender, segregation of the sex is more prevalent after kindergarten. Still, female achievements in science and mathematics are higher than male through all the GCC country according to the UNESCO. Although Arabic is the official language of the GCC country, English has become the global language for science. Implementing of any technological advancement must be regulated by the Islamic rules, and the quality of technology as the rate of technological advancements faster than the rate of STEM program implementation at school. Despite the general wealth in the region, minimal financial resources are allocated for STEM implementation. The difference and the similarities between setting and sample of the two countries. The initial research occurred at Kansas State University in the United States, and their replication occurred at Kuwait University in Kuwait. A total of 165 students participate, including 100 students in the United States and 65 from Kuwait. U.S. participants were comprised of 67 male and 33 female from summer STEM institutes, while Kuwaiti participants, including around 52 males, 48 female, from Little Engineer Workshop. Although the United States required no designation between gender in education registration, Kuwaiti programs request them to be divided into female section, male section, and mixed sections. The difference between the two countries are due to the transformations factors such as language, religions, and gender. Data was collected using pre-post surveys and Kahoot questions. We used two instruments to collect those data. The first instruments measure computational thinking self-efficiency score. All the questions were measured using 5-value Likert scale from strongly disagree to strongly agree. For the second instruments, it's measure student understanding. The question cover the mighty microcontroller learning outcome, such as the coding principles and the electricity in the circuits. The research was carried out over 4 3-hour sessions for 3 weeks, excluding daily break time. On the first day, before any material was taught, students completed a survey about computational thinking and played Kahoot after each session to test their knowledge about the material. Students retook the computational thinking survey on the last day of the program. The workshops were identical to the Mighty Microcontroller lessons in USA, with only minor changes and translation for the Kuwaiti group. This study analyzed student interaction in the STEM program to understand barriers that arise from adopting the program in Kuwait. The following research questions were considered. The primary factors that impact the application study were language, religion, institute, technology, and gender. Because the Mighty Microcontroller program was designed in English, multiple obstacles appear when we try to teach it in Arabic region. So we asked parents to indicate the preference language to their children. Arabic slang were typically used to deliver the program, while maintaining English words of the concepts. Likewise, translating sometimes made it harder to understand. For example, kids are familiar with the word loop, but using Arabic translation would confuse them. Religion and traditions comprised the second major factor that impacted this replication study, because parents did not want their children to be in a group with mix or the opposite gender. The class were divided into male and female sections. Not only did the education system influence the teaching medium, but also influence student background. Students also encounter obstacles while they were taking the self-efficiency survey, because this was the first time Kuwaiti students had participated in this type of assessment. Students' computational thinking abilities improve in almost all concepts. Questionings and testing and debugging scores show significant increase to the social factor since competition between teams were very high. Female participants exhibit a similar trend between their male concept except the decomposition, which was potentially due to the student needing to employ high level of thinking. Obvious gain is student self-efficiency with computational skills over female, but not male. Male score did not show any statistically significant, so effect size could not be compared between gender. The Comparison of scores showed that the US demonstrated more significant effect size in abstract, parallelization, and control flow, but Kuwait showed higher gain only with testing and debugging skill. Same trend with course knowledge, where US male has a higher score than Kuwait males, but that in contrast of the females, where Kuwaiti females has a higher score in course knowledge than US female. For the CT skills, Kuwaiti female has a higher in algorithm, control flow, and testing and debugging than the US female, while US females score higher with abstract, data, and parallelization, and the rest are not statistically significant. The replication of the pilot study in Kuwait was a unique experience that offered valuable insight. Positive insights include the high rate of acceptance and participation in both countries. Some negative insight, including unexpected obstacles that needed to be avoided or remedied. Overall, the results revealed a promising start with many positive indicators. Further investigation should be undertaken in this field on a larger participant group, especially in the neighboring GCC country. And thank you. Any question?